Now that we know how to build a JSON record, let's learn how to parse some data from a JSON record using the JSON Parse instruction in Do More Designer and a BRX PLC. The purpose of a JSON Parse instruction is ultimately to get a value you need from a JSON record. If the JSON record has nested objects, it will take multiple JSON Parse instructions to get what you want because the instruction will only search the top level. It will not drill down into all the nesting looking for what you want. Each individual JSON Parse instruction you use extracts data in one of three ways. The first way is it extracts a single value from a name-value pair in an object based on searching for the name. In other words, it will search the top-level objects in a JSON record looking for the name you specify. When it finds it, it gives you the value portion of that name-value pair. This implies, of course, that you already know the name of the name-value pair that you're looking for. So, for example, if the record looks like this, containing two name-value pairs, and you tell it to look up latitude, it will search the object, find latitude, and return its value of minus 16.92. The second thing it can do is exactly the same as the first thing it can do, except the search is based on a zero-based index number instead of based on the name. This may be useful if you don't know the name, or you're iterating through all the top-level objects for some purpose. So again, if your record looks like this, you can get the same value you got before, only this time you tell it to look for index 1. It will look at the top-level objects only until it sees index 1. Having found the object at the index location 1, it will now return the same value you got before, minus 16.92. But not only that, optionally, you can also make it give you the name of the value it found. The third thing it can do is extract a single value from an array of values based on a zero-based index number. So, if your array looked like this, and you told it to find number 2, it will do so and give you the value of 362. But that's all well and good if it works. But what happens if you receive a malformed JSON record? Or the data wasn't arranged in the way you anticipated? Or perhaps you don't really know what the JSON record is supposed to look like? What then? Well, the JSON Parse can optionally give you a status double word to help you out. Let's say we pick D1000 as the status double word. What will it tell us? The upper word of this double word will return a code. But the thing is, the code can be positive or negative. If it is positive, then the lower word is divided into 2 bytes, representing the input type code and the value type code. More on that in a minute. If, however, the code is negative, then the lower word by itself will indicate the character position in the JSON record that it saw a problem. How would you look at these individual pieces? That's easy. You simply use the proper suffix and cast that value. So you can see here that :W1 means the upper word of D1000, and :UB1 and :UB0 mean the unsigned bytes of 1 and 0. Similarly, the :W0 means the lower word of D1000. So what do these individual values mean in this double status word? First, and most importantly, a 0 in the code word means your JSON parse was unsuccessful, however the JSON record that it searched was okay. No fatal errors were found. In other words, it was well formed. If it contains a 1 in the code word, then your JSON parse worked. If, however, the code word is negative, then you can see here the various meanings. These meanings, of course, are given detail in the help file for JSON Parse. But in this summary box, you can see the various problems encountered. But back to the positive code. The input type byte tells us what type of JSON record it detected when it did the search for what you wanted. A 0 here means that there is some syntax error, like a missing colon or something. The value type byte tells us what kind of value is extracted. Armed with this information, you can now write very complex ladder logic to figure things out if need be. That involves some tedious work, but it can be done when required with this abundance of information. If, however, you know exactly what kind of JSON record you're parsing, which is the case most of the time, then of course you don't need to know any of this, but it's there if you need it. So how do we go about extracting data from, say, the JSON record shown here? If what you're after is on the top level, a single JSON parse will suffice. For example, the date here designated as DT is a name value pair on the top level. A single JSON parse can search the JSON record for DT and find the value and store it wherever you want. How do we know what is on the top level? By the indentation. The top level objects are only indented once. However, if what you want is down a level or two, then multiple JSON parse instructions are required. For example, if we wanted speed, we could not get it with one JSON parse because it's actually stored under wind. Thus, in this case, we need two instructions. The first to get wind, which would be the entire string contained in the curly braces, and the second to get the value of speed from that. Notice speed is indented not once, but twice. In our specific example, which we'll show you in ladder logic, we're going to extract some data from a JSON record provided by a popular weather API. And we're going to use that data to make a weather report for a certain city. We'll get that JSON record using a do more BRX HTML command. Ultimately, we will extract description, temp, date, time zone, and name, as here are all highlighted. First, we want to get the date time, which is DT. This value is in 1970 epoch format, that is, the number of seconds that have passed since January the 1st, 1970, but it is also in universal time, so we have to deal with that as well. The DT is on the top level, so the first JSON parse will get the value and we'll store it in D1. We'll then use an epoch to date instruction to convert that value to a date time, and we'll store that in user date time structure UDT0. Since it's in universal time, we'll use another JSON parse to get the time zone. This value will help us adjust to the proper time. This time zone is also in seconds. We'll store this value in D2. Then we'll use the DT offset instruction to adjust the date time in UDT0 with the time zone value that we have stored in D2, and we'll store that final date time in UDT1. Now we have the proper date and time for the time zone of our city. Next, we want to get the current temperature for that city. This is in temp, but notice it is stored inside of main. Also notice this value is in kelvins, another issue we'll have to deal with. We'll use a JSON parse to get main first and store that in string SL0. Another JSON parse will search SL0 and retrieve the value from temp, and we'll store that value in R0. We'll then use a math to calculate Fahrenheit and store that in R1. We now have the date and time and temperature of our fair city. Next, we want the description, but it's located inside of an array. Notice the square brackets above and below the green highlight. Notice also that the description, which is what we're after, is indented 3 times. The weird thing is, in this case, the array has only one value, a single object highlighted in green. Now normally an array would contain multiple values or objects separated by commas, but it's not so in this case. Further, this array is inside of weather. Thus, it is going to take 3 JSON parse instructions to get what we want. So we'll use one to get weather. We'll store that in SL1. Then we'll use the second one to get the only value in that array. Thus, it will be at index 0. We'll store that in SL2. Then we'll be able to get the description out of SL2 with a third JSON parse. We'll store that in SL3. We now have a description of the weather of our city. Finally, we'll get the name of the city. This value is on the top level. This JSON parse will store the name in SL4. In the end, we'll have the date, time, location, description, and temperature of the weather we ask for using the data highlighted at the right. All stored in memory locations and properly adjusted so that we can make use of it in our BRX PLC. This will be used to make our weather report. Once we have that report, we could, for example, send it in an email to some interested party, or whatever. Lastly, as an added bonus, we'll demonstrate how we can get various objects from the top level, storing the value in SL11 and the name in SS3, all by using a zero-based index. We'll use V0, instead of searching by name. The numbers stored in V0 will index the top-level objects. There happen to be 13 top-level objects in this particular JSON record, as you can see by the underlines indicated here. Now let's see how this is done in ladder logic. Okay, I have a main here that I've done in ladder logic. You'll notice I have a JSON Parse program that will be started with C1. So I turn on C1 and I've got this program running. I pull it up. In the first rung here we have a C10 that's going to go out and use an HTTP command instruction and get some data from api.openweathermap.org. Right now just know that it goes and it pulls this website and gets some weather back in a JSON data format. Now it's going to stuff that into JSON data 7 string. Each string in that block is 1024 characters long. So when I execute this C10, you can see it goes out and gets the data. Here's the data right here. And you can see that the length is 463 bytes long. So that was quite a bit longer than the longest standard string in the DoMore, which is SL, which is 256 characters. So now we'll use this really nice tool over here, and we'll go to the wrench and pick JSON Pretty. And you can see here's the data as it came in, but over in the right pane you can see how it put the data in a nice format. So you have all of these objects inside of this that we're going to parse out and get what we want. So we close this guy out. So the next thing is we're going to start the parsing. So here you can see I'm going to go out and execute this parse on that string we just got. I'm going to look for the DT parameter, and when I get it, I know it's going to be a numeric value. If I didn't know it was going to be a numeric value, I would put it in text, okay, because this is where I could store that. But down here you can see I know it's going to be a numeric value, and I'm going to store that numeric value in D1. So that's what this JSON parse is about. So when I hit C11, it goes out and gets that value. Now, let's go up here and let's just verify it. Let's look here at this string again, and we'll pull this down. So you see it searched through this record, the JSON parse did, until it found that. There it is. And that's the data. You see that it's a number, and that's exactly what it stuffed into D1. Let's open this guy up again, and we'll look here at the return results. That's that status word I told you about. I chose D1006. And so you can see when you got status turned on, you can see that it intelligently divides it up. Let's get the cursor off of there. And it even interprets it for you and tells you what those values are. And now let's see what we're going to get next. So here's C12. I'm going to take this time value that I got, which I told you was in 1970 epoch format, and I'm going to convert those number of seconds that have passed since January 1, 1970, and I'm going to convert it using this epoch to date time instruction, and it will convert it and stick it into user date time 0. So when I execute that, you can see that it converted these seconds into something actually useful. But remember that this is universal time. So C13, what are we going to get with C13? We're going to go get the time zone. Alright, so let's execute that one. Now that I have the universal time and the time zone, then I can go down here and I can use this DT offset instruction, and I'm going to take that universal time that's there, adjust it by this D2 number of seconds, and stuff that into UDT1. So when we do that, what do we get? Now it gives us the actual time we were after. Next is we're going to hunt for main. Now this one, if you'll remember, I know it's going to be a string, And so I'm going to grab it and stuff it into SL0. So let's watch that happen. C15. There you can see it's showing up in SL0. Now this is a little bit tricky. So what I'm going to do is I'm just going to go here, and it's always going to point to this JSON input string. Okay. I know right now that this SL0 is going to contain some JSON data, but the instruction doesn't know that each time. So we'll hit this and pull this guy down here, and I'm just going to go up here and manually enter SL0. So when we told it to get main, before I hit enter here, it should grab this, it should find it and give you this data right here. So let's see what happens when I hit the enter button here. And there it is. So see, it went into and found main, and it grabbed exactly that piece that we wanted it to. So that's what this is right here. So we'll scroll this up a little bit more. And now we'll go to this rung here. Now once I got main, I got that piece out of there. Then it was a piece that I wanted out of that, which had the temp. I was after the temp value. Again, let's go look at this with this JSON pretty. So here you see that's the main chunk that I pulled out, and I'm looking for this value right here. So that's what I'm telling this next JSON parse to do, is to grab that temperature value. Again, I know it's going to be a number, and so I also know it's going to be a real number. So I'm going to stuff it in a real value. So you can see right here, this one gets the string we just did, tells it to look for temp, and I know it's going to be a numeric, stuff it into R0. So C16, there it is. That temperature value is in kelvins. So my next instruction down here is just going to do some math to convert the kelvins to Fahrenheit. There it is, 78.24 degrees Fahrenheit. Next JSON parse, I'm going to take that big data again, and I'm going to go get the weather. Remember, this one was going to take 3 to get what I want out of this one. So we'll pull this guy back up again using JSON pretty. I'm after something inside weather. It's the description. So you see it's going to grab this weather, but remember, see this square bracket here indicates this is an array from this bracket to this bracket. And the problem is, of course, this array only has one object in it. So I've got to get weather, which is going to pull this array up. Then inside this array, I've got to get this object. And then inside this object, I'm after this description. So it's actually going to take 1, 2, 3 JSON parses to get exactly what I want. So let's do that one. Let's do the first JSON parse. I hit that guy, and now it should get that array out of there. And you can see it starts with that bracket, so it got that array. So you can see, since I already know that, I tell it to get that string, and I tell it 0-based array field index, get the first thing in that array. I know it's 0. I know it's going to be some more text, and we'll stuff that into SL2. So we execute this one. And now you can see how it removed the brackets, or the square brackets. So now we just have that first object out of that array, and there it is. So that is now in SL2. C20. Look for description. Find that I know it's going to be text. Stuff that into SL3. Here we go. There it is, clear sky. So I got what I wanted out of there. Now I'm done with that one. So what's the next thing I'm going to do? Well, the next thing I'm going to do is I'm going to go get the name. So if we execute that, we got it. So now, just to sum up, I kind of put all the things I wanted right here in a row, and you can see my UDT1, it's the year 2020, October the 21st. It is Wednesday, and the hour is 15, which is 3 o'clock in the afternoon, 3/19/29. The city is Bluff City. It's clear skies, and it is 78.24 degrees Fahrenheit. So I could actually use something like a string print or an email instruction and put this data in some English and send it to someone if I wanted to. So that's how you use the JSON parse instruction to get the data out that you want. Now, in this little demonstration, all I'm going to do is I'm going to use that long string again, the original string I got from the HTTP command, and I'm going to just show you how you can also index through these top objects. So remember, here's the long string, and what the JSON parse will allow you to do is all the top objects, you can just iterate through them. So to do that, you can see this is the original string, that's the input. I'm going to use a 0-base array, and I'm going to use V0 to do that. And whatever field name it finds at this index, it'll stuff that name into SS3. I know whatever it gets, I'm just going to stuff it in a string, because sometimes it's a value, sometimes it's a string. I'm going to stuff it in a string all the time, so we're safe there. Put it in SL11. And then I'm going to form a string print that's just going to have the index that I used, a dash, the name, a colon, and then what it found, and stuff that into SL12. That's why I'm doing that. And then, of course, I'll automatically increment V0 to its next value, and also reset this. So right now, it should be set to 0. So when I hit this, you see it gets coord. And now that isn't, the length of that one is actually 39. So if I go down here and read that, you can see that's what it found. Hit this again, and you see it used index 1, and it found weather. And if I want to see what actually there is, you can see it grabbed all of that. There's the base, main, visibility, wind, clouds, DT, SYS, time zone, ID, name, and coordinates back to 0. That's how you would use JSON Parse in a BRX PLC to get what you want out of a JSON record. Thanks for watching.